Hey, welcome back. Now, we know that we need to get the hit result under the cursor. We're going to talk a little bit more about how that works and what that means in this video. So our goal is to get the hit result under the cursor and show this location, and we can do so by drawing a debug sphere. We'll learn how to do that as well. So let's talk about something called a hit result. In games, we'll often want to do something like this. We'll have a point in space. We'll call this point start, and it has the type f vector. And we'll have an end location. This will also be a point in space of type f vector. Now let's say we'd like to draw an invisible line from the start point to the end point. And at the moment we draw this line, we'd like to see if there are any objects in between the start and end locations. Now if there are, then this line that we're drawing in space is going to hit that object on the surface. When this happens, we call this a hit event. Now, when we draw an invisible line like this, it's called performing a line trace. And when we hit something, we say that we have a trace hit. Now, if we do hit something and get a hit event, then the trace hit stores information in a struct called a hit result. Its type is fHitResult. Now, the fHitResult struct contains variables that store information about the hit event, including the hit location as an f vector in space and the actor that we hit, among other information. Now, when we perform a line trace, we do so by specifying a collision channel. Usually with line traces, we choose the channel called visibility. There exists an enum called eCollision channel, and in this enum, there's an enum constant called ECC visibility. This is one of the parameters we specify when performing a line trace. Now, if we specify the visibility channel, that means objects that are set to block the visibility channel in their collision settings will register hit events. Any objects that are not set to block the visibility channel will not generate hit events. Now, we would like the trace result under the cursor. Imagine we have the screen here, and here's our cursor. Now, at the tip of our cursor, we have a point on the screen. When we use the function to get the hit result under the cursor, what happens is we have our camera, and it may see some objects in the world, such as the floor here, and we're performing a line trace from the camera at the point on the screen corresponding to our cursor location, and we're shooting the line trace straight out into the world. And if we hit something, we'll generate a hit event and store the information in a hit result struct. So let's find out how we can do this. I'm here in tank.cpp, and what I'd like to do is get the hit result under the cursor every frame, which means we need the tick function. So again, we're going back into BasePawn and finding our tick function here. Now we're not using it for anything in BasePawn, so we can move this function into the tank class, just like we did with BeginPlay. So I'm going to highlight the function declaration along with its comment and copy it. And after that, I'll delete this whole section, public and all. And then I'll go back into tank.h, and here in the public section, I'm going to paste the tick function declaration. Now we're not using it in BasePawn, so I'm going to remove the tick function from basepawn.cpp. Now it's gone from BasePawn. Now we have it here declared in tank.h, but we also need to define the function in tank.cpp. I'm going to do it here in tank.cpp just under setup player input component. So we're going to say void tick. It takes a float called delta time, and there's our body. Now again, we need a tank just before the tick function along with the scope resolution operator. And we also need to call super tick and pass in delta time. So we now have tick on the tank class. What we want to do is get the hit result under the cursor. So here's how we do it. The function we're going to use exists on the player controller called getHitResult_cursor. We've been talking about this. Now here's the syntax. It takes a trace channel. Remember, we need to specify a trace channel, and we're going to use visibility. Now we have two additional input parameters. The first is a bool called bTraceComplex. We'll talk about what that means in a second. And the third input parameter is an fHitResult. Now I'm going to click on fHitResult just to see this type here in the documentation. And if I scroll down, we'll see some of the variables. One of them is called actor. and its description says actor hit by the trace. We also have this B blocking hit, which indicates if this hit was a result of a blocking collision. Now, among the other variables, we have things like impact point. This is the location in space where we actually hit something. So why don't we go ahead and attempt to call this function? We first want our player controller. And thanks to what we did here in Begin Play, we have player controller ref. Now the first thing we should do is check to see if player controller ref is valid. We can always pass a pointer into an if statement. It'll return true if the pointer itself is not a null pointer. If it is a null pointer, it'll return false in an if statement and will never reach the inside of the if statement. It's always a good idea to check our pointers and make sure they're not null before we use them. Now we're going to get our player controller ref, and we're going to use the arrow operator to call the function getHitResult under cursor. Now we can see with the pop-up that we have 3 input parameters. The first is the trace channel. We're going to use eCollisionChannel, and if we type 2 colons, we get a drop-down that shows us all of the different enum constants in the eCollisionChannel enum. We want to use visibility, so we're going to type ECC visibility to specify that we're using the visibility channel. Now the next parameter is called bTraceComplex, and we're going to pass false into this. Now we'll discuss in a few minutes what this means, but for now we're going to use false. Now for the third parameter, we need a hit result. This is a struct of type fHitResult. Now if you hover over this, you'll see that fHitResult is being passed in as a reference, as indicated by the reference operator that looks like an ampersand. Now usually when you pass something in as a reference, it's a const reference, meaning the function won't be able to change it. But here we're passing in an fHitResult as a non-const reference. This is generally a hint that the function is designed to change this input parameter directly. What getHitResult under cursor is going to do is fill in those variables in the fHitResult with information about the hit result. This means we need to pass one of these fHitResults in. We're going to create a local variable here in the if check of type fHitResult, and we can call this hitResult. And we can simply pass this in as the third input parameter. Now, after we've called this function, then this hitResult will be filled in with data about this line trace. For example, we can access hitResult.actor to get the actor that was hit, or .ImpactPoint to get the point in space where we had the hit event. So the hit result is what we will use to get information about the line trace. Now, often it's nice to be able to see the result of a line trace. We can easily visualize the result of a line trace by drawing a debug sphere. Debug spheres are simple shapes that we draw in space, and they're great for showing a location, and we use these when debugging. We don't actually use debug spheres in a shipped game. So let's see how we can draw one of these debug spheres. Now here's the documentation for a function called drawDebugSphere. It exists in drawDebugHelpers.h. So we can copy this header and include it wherever we'd like to call drawDebugSphere. Now look at all the input parameters. First it takes a world. This way it knows which world to draw the sphere in. It takes an f-vector for the center of the sphere, as well as a float for the radius. It takes an int32 for the number of segments for that sphere. The more segments, the more round the sphere. It takes an f-color. This way it knows which color to draw this sphere in. It wants to know if you want persistent lines. In other words, should the lines disappear immediately or should they persist? If they do persist, it wants to know the lifetime of the sphere. When should it stop drawing the sphere? If you don't draw persistent lines, say you'd like to draw it for a single frame, then you would pass -1 in as the lifetime. Now the last two parameters are optional, so we'll keep this simple by only discussing the first 7 parameters. Let's see how this works. I'm going to draw a debug sphere. Now up at the top, I'm going to include drawDebugHelpers.h. That's where this drawDebugSphere function is declared. Now let's go down to Begin Play and just simply draw a debug sphere to see how this works. So I'm going to call drawDebugSphere. And the first input parameter is a uWorld. We can get our world at any time, by calling getWorld. GetWorld returns a UWorld pointer to our current world. So that will satisfy the first input. Next, we need an F vector for the center of the sphere. Now we're calling this in begin play. So I can simply call getActorLocation. And this will get the location of our tank pawn since we're in the tank class. Now I'm going to raise the sphere up by a bit. So I'm going to add an F vector with 0.f for the x, 0.f for the y, and say 200.f for the z. Now I'm going to place these input parameters each on their own line so it's clear what we're passing in for each input. The second input is getting this expression, which is the actor location plus a vector pointing upward with a length of 200. Adding these two vectors together will give me the location of the tank raised up in the z-axis by 200 units. Now the next input parameter. It's going to be the radius of the sphere. I'm going to choose 100.f, just so we can see what a debug sphere with a radius of 100 looks like. Next is the number of segments. I'm going to choose 12. We'll see what that looks like. Now for an F color, there exists an F color class, and it has lots of colors built in, such as red. Now for the Boolean called bPersistentLines, I'm going to choose true. And for the next input parameter, we have the lifetime. Notice it has a default value of -1. That means by default, it'll draw the debug sphere for a single frame. But I'm going to pass in 30.f so that we get the sphere for 30 seconds. And I can omit the last two parameters. So here's our function call to draw debug sphere. Let's compile this and see what it looks like. Okay, so I'm back in the editor. I'm going to open a second window so we can see this in full screen. I can go to Window, Viewports, and select Viewport 2. And now I see this second window. It may not be full screened when it opens up, but you can always maximize it. Now from here, I can play the game with Alt-P. Now check this out. Here's our debug sphere. Notice it's not perfectly round. We chose 12 for the number of segments. The more segments you choose, the more lines it takes to draw the sphere. Now this is a sphere with a radius of 100. It's pretty big. And the center of the sphere is at the location of the tank plus 200 units up in the air. So this is how we can draw debug spheres. So your challenge is to draw a debug sphere using the trace result under our cursor. So draw a debug sphere in our new if statement where we're checking if player controller ref is not null. Now, using our hit result, get the impact point from the hit result and use that as the center for the sphere. Now, for the persistent lines input parameter, use false, and for the duration, use -1. And this will result in drawing the sphere for a single frame, which is okay because we're calling this every frame inside the tick function. So pause the video and draw the debug sphere in the tick function. Okay, so I'm back here in tank.cpp. Now I have this draw debug sphere function call here in begin play. So I can go ahead and copy that and just remove it from begin play. And we're going to go back up into tick here inside of our if statement. And I'm just going to paste it here and we're going to change some of the input parameters. For one, we're changing the location for the center of the sphere. We're going to use the hit result. So I'm going to say hit result dot impact point. Now for the radius, I'd like to make this a bit smaller. Let's make it about 25. That's okay if you didn't do that. I'm just doing this so the sphere is not so big. Now, the second to last parameter we're passing in is for persistent lines. I'm going to pass in false, and for the duration, instead of 30 seconds, I'm going to use -1.f. That way, we'll get a sphere for a single frame, which is okay. Again, we're calling this in the tick function, so we'll be calling this every frame. Let's go ahead and compile this. Now, back in the editor, if I hit play, now check this out. I have a debug sphere, and it's being drawn at the impact point for the line trace under the cursor. Now we can move this up the walls and on other objects, and the trace is hitting these objects because they're set to block the visibility channel. Pretty awesome, right? Now, I promised we would discuss tracing complex versus tracing simple. I'm going to show you something. While we're playing the game, let's click in the viewport so that we have control over our pawn. Now hit the tilde key and type the console command show collision. Now, it may not be so easy to see on my screen, but you can definitely see it on your screen. Notice the collision for our ponds. Not only can we see the capsule, but we can see this collision volume around our tank and turret meshes. This is simple collision. Let me just show you real quick where we can see the simple collision. I'm going to go into Assets and Meshes, and if I double click on, say, Tank Base, here we're looking at the complex collision. If I click on this show icon here at the top and select Complex Collision, I can see all of the polygons in the complex collision, and there are a lot of them. If I click the show icon again, and this time check the checkbox next to Simple Collision, notice there's another collision volume. This is called a collision hull, and it has a great deal less geometry. There is a smaller number of polygons with this collision volume. This is what the physics engine uses to detect for overlap and hit events. If it were using the complex collision, it would require a great deal more computations. This is why we have simple collision volumes. So it's much better for performance whenever doing a line trace if we trace for simple collision instead of complex collision. So now we've gotten the hit result under the cursor. It took some work to get there, but now we have it, and we've proved it by showing this location with a debug sphere. This is a nice way to confirm that our trace hit is working. So now that we know it's working, we can use that location to rotate the turret on our tank. And we'll do that in the next video. I'll see you soon.